As we zoom in from the heavens, one planet stands out: Earth. Every life supporting feature balanced, ordered, and finely tuned, as if set by the hand of a master designer.
Hey friends, I'm Christelle Miller, also known as Professor Woodsy Wild. Welcome to Wonderfully Made Earth Edition. Have you ever dropped something and watched it fall straight down, like a pencil, a leaf, or your favorite snack? That invisible pull that makes things fall, it's called gravity. Gravity keeps your feet on the ground, keeps the oceans on the earth, and even keeps the moon circling our planet instead of drifting away into space. A long time ago, a scientist named Isaac Newton wondered, if the same gravity that makes an apple fall is also pulling on the moon, could there be one rule that explains everything? Newton believed that the universe was designed with order, and he thought gravity was one of the laws that God put in place. He discovered a mathematical formula that describes how gravity works, how strongly things pull on each other, and how that pull changes with distance. His equations still work amazingly well today. Later, another scientist, Albert Einstein, added something deeper. He suggested that gravity isn't just a pulling force, but that massive objects actually bend space itself and other objects move along those curves. This idea is called general relativity, is widely accepted today because it explains things Newton's equations couldn't, like black holes, GPS satellites, and ripples in spacetime called gravitational waves. But here's what's really fascinating. Even with all this knowledge, scientists still don't know the ultimate why behind gravity. We can describe gravity, measure it, predict it, but its deepest cause is still a mystery waiting to be explored. And Earth's gravity isn't just strong or weak, it's precisely balanced for life. If our gravity were a little stronger, everything would feel heavier. Birds would struggle to fly, and tall trees might not be able to grow. If gravity were a little weaker, things would float strangely. Our atmosphere wouldn't stay wrapped around our planet, and even our oceans would slowly escape into space. So, gravity sits in a very narrow range that lets life thrive, one of the many finely balanced features of our world. Now, let's try a simple experiment to see how gravity pulls on everything the same way, even when things look very different.
Hey friends, right now we are going to try a simple experiment to demonstrate the force of gravity. We have here two stools with a board suspended in between. That is so that you see that both objects are dropped at exactly the same time. Newton liked the apple, so we're going to use an apple for the heavier object, and the light object there is a little ping pong ball. Those are very light. All right, friends, which one do you think is going to hit the ground first, the apple or the ball? I want you to watch and listen very carefully, okay? Here we go. We're going to test this. 1, 2, 3. 3.
Hey friends, pretty amazing, right? Even though our objects had different weights, they still hit the ground together because gravity pulls on everything at the same speed. Now I want you to try this at home. Grab two safe objects of different sizes, start them at the same height, drop them together, and watch closely to see what happens. Thanks for exploring with me today, and remember, the Earth is wonderfully made, and so are you.